Morning, all of you. In today's session, we are going to start with how can we regard hydrogen as the fuel of future, part 2. In the earlier session, we completed. So what is the important specifications of hydrogen? What are the properties of hydrogen? How can we synthesize hydrogen in different modes? And what are the important advantages of hydrogen over other elements? And what are the ultimate applications of hydrogen? Those topics were completed, and even we regarded hydrogen as the fuel of future. Justification for that sentence is also provided in the earlier session. All these are available on the channel called World of Competitive Chemistry. Now, we are going to continue with how many types of hydrogens are available and what kind of synthesis are possible. Is it possible to synthesize hydrogen from the garbage? How can we convert that waste into a valuable fuel? So that topic is going to be discussed in detail in today's session. And moreover, what are the important applications of hydrogen in our automobiles and various other applications also going to be delineated. Now let us enter into our today's concept. That is, how can we consider hydrogen as the fuel of future? Part 2. Right. So this is Dr. Kavita Kothireddy. I'm going to describe you how can we regard hydrogen as a fuel of future. Now let us see, hydrogen can be categorized into green hydrogen, blue hydrogen, gray hydrogen, pink hydrogen, and yellow hydrogen. This kind of classification is provided purely based on the origin from which we are going to synthesize this one. Right. So green hydrogen regarded for if hydrogen synthesized in the green manner, green methodologies, hence you can regard this as a green hydrogen where the process entirely sustainable in nature. Right. So if you're going to harness this solar radiation by the photovoltaic cells, or else here windmills are used to harness the wind power and can be stored energy in the form of electricity in the battery. So either of the process can be regarded as a renewable and can used through the sustainable process. Hence, we can generate the electricity either of the manner, and that electricity is used to split the water molecule. Being water available in the plenty of quantity can be regarded as a renewable as well. And this renewable energy used to split the water molecule under the external current, so that splitting of water into elemental species like a hydrogen and oxygen. Hydrogen can be stored in a proper way, and that can be utilized whatever applications we need. This entire process where hydrogen generated is purely regarded as a green hydrogen because the entire methodology is proceeded with the green protocols. And next is about blue hydrogen. Blue hydrogen is given for the process where we are going to start with the natural gas as a starting material. Natural gas is a low molecular weight hydrocarbon where C1 and C2 carbons are kept under this category. And methane, ethane is a major composition of this natural gas which is subjected to the chemical process in order to split this molecule so that hydrogen is extracted. So here compression get carried for this natural gas and reformer where the chemical reactions get carried and the splitting of this hydrocarbon into the fragments are possible, and here hydrogen is collected over here and stored and further applied. How we are using this green hydrogen. And any other byproduct generated over here will be carbon dioxide, and that carbon dioxide is properly treated. We are not going to emit, being it is a greenhouse emission and used to rise the temperature of the atmosphere and cause the global warming. In order to avoid all these hazardous impacts in the environment, this carbon dioxide is properly treated by the sink called CCUS. So here carbon absorbing medium will be there so that here it will become non-toxic and will not be emitted into the environment. So blue hydrogen also not having any kind of adverse impact on the environment. In any other process is about gray hydrogen. Gray hydrogen here, the starting material remains same, just like a blue hydrogen, where natural gas was taken into the consideration as a starting material and subjected to the chemical processing and reforming, get carried, hydrogen get extracted, and carbon dioxide evolved during the process as a byproduct. Cannot be treated, cannot be stored in any kind of process. That's a reason why gray hydrogen is not that preferred, because here carbon dioxide get evolved into the environment so that it may show the adverse impact. In either is about pink hydrogen, where harnessing of hydrogen is possible in the presence of nuclear reactions, either nuclear fission or fusion reactions get carried, so that hydrogen evolved get considered as a pink hydrogen. And here is about yellow hydrogen. Yellow hydrogen regarded for the hydrogen which harnessed, which got extracted, which got synthesized by means of solar radiation. Solar radiation is used to split the water molecule by the process called electrolysis, so that here hydrogen generated can be purely regarded as a yellow hydrogen. These are the various kind of categorization of hydrogen based on the starting material we are choosing for its manufacturing. Now let us see in detail description for these hydrogens whichever available. And here along with these you can observe the application of hydrogen. Hydrogen is the primary element in the hydrogen oxygen fuel cell construction, which is the primary energy source for rocket fuel. Here you can observe the categorization of hydrogen over here: gray hydrogen, blue hydrogen, and green hydrogen. Gray hydrogen, the starting material, is a natural gas which gets splitted into elemental species like hydrogen and carbon. Whatever present in the natural gas get converted into carbon dioxide, but here carbon dioxide emitted directly into the environment, that may show the adverse impact on the environment. And neither is about blue hydrogen. Again, here the starting material remains same, but hazardous impact got controlled over here, because whatever byproduct carbon dioxide is there, that get stored and reused. Hydrogen get captured and can be utilized for the various applications, whatever which are already predefined. So this is about a blue hydrogen, and next is about green hydrogen. Green hydrogen is purely proceeded with the sustainable protocols where splitting of water molecule into a hydrogen and elemental oxygen are possible. Electrolysis get carried, and the power generated either by solar or wind power get utilized for the splitting of water molecule under the external current. And here this there is no carbon dioxide emissions, any other emissions. So here emission free process, green hydrogen. So zero emission is possible during the process, and in either application is also provided in continuation to this one. Here hydrogen is the essential element for the process of production, especially in the metallurgical process. Most of the combined compounds, pure metal, get extracted by the process of reduction, where hydrogen is the essential component in order to perform the reduction process. Reduction simply regarded as the addition of hydrogens. And detailed discussion is provided to you regarding this green hydrogen production. Green hydrogen is extracted using the method where greenhouse gases emissions are zero. So here there is a specific concern regarding the greenhouse gas emissions. These are completely discarded during the process of green hydrogen synthesis. As the name suggests, the production is sustainable and 100% environmental friendly in nature, and it is adopted by most of the bulk synthesis or industrial scale synthesis of hydrogen by so many countries, being it is 100% acceptable either by society and also by environment as well. Green hydrogen is the most commonly produced kind of hydrogen, and by the process called electrolyzation of water molecule, and the device is said to be electrolyzer. Electrolyzers are subjected to electricity in order to split the water molecules into hydrogen and oxygen, being water available in the plenty of quantity. Earth covered by around 75% of water, only 25 terrestrial open region is available. That's the reason why there is no any adverse or any kind of hurdle regarding this synthesis of green hydrogen. Only we have to conscious about the environment. That is only the key point in order to achieve this green hydrogen, because raw materials are abundantly available. The key to this method producing green hydrogen is electricity, and it can be synthesized from the renewable sources such as wind and solar power can be taken, and no greenhouse emissions and consequent global warming can be 100% subsided. The pathway of water molecule splitting. Here we are taking 2 moles of water molecule where water composed of H2O, 2 hydrogens and 1 oxygen will be there. And whenever these water molecule gets splitted by means of external electricity, oxygen and 2 moles of hydrogens got generated. This is said to be a balanced equation. And how can we say this is a green hydrogen? Splitting of water molecule, water taken as an electrolyte over here, and the cathode and the anode fitted with the external circuit. Hydrogen evolved at a negative terminal and oxygen evolved at the positive terminal during the process of electrolysis. Now, green hydrogen is a hydrogen produced by splitting of water molecules by the process of electrolysis. In order to get this electrolysis, electricity is required as a power, and splitting of water is possible either wind and solar radiation get harnessed, and there is no any kind of other adverse emissions or byproducts will be released during the process. Only hydrogen, oxygen are the products generated without any kind of emissions, hazardous emissions into the environment. That they refer to as a project Petrofac is supporting Australia mentioned at the beginning. So this is the kind of pattern which adopted by so many countries, and they are advancing towards, especially 21st century is mostly concerning regarding this not only development of the human society, but also in harmony with the environment. That's the reason why all these conditions are coming into the picture, and these kind of explorations are of higher priority of one's nation. Gray hydrogen is another kind. So here detailed description for gray hydrogen is also provided to us. Gray hydrogen where we are going to perform either SMR or ATR kind of splitting of natural gas. Natural gas was taken into a starting material over here. And whenever natural gas is splitted by the process of SMR regarded as a steam methane reforming. That means methane was taken, added with the steam. Hot water vapor is regarded as a steam, so that your reforming process get carried, splitting of methane into hydrogen and carbon dioxide are possible. And one more process called autothermal reforming. Autothermal reforming in the sense we are rising the temperature to very high, so that here splitting of natural gas is possible, and release of hydrogen along with the byproduct of carbon dioxide. This is a purely thermal combustion process. Here oxidized product, either complete or partial oxidation is possible for this carbon. Complete oxidation gives rise to your carbon dioxide. Partial oxidation gives rise to your carbon monoxide as a byproduct over here. So this is the impact. A slight impact is provided because the carbon monoxide is considered as a toxic gas, which is not at all preferable. If partial combustion is possible, that may release this carbon monoxide, which is hazardous some extent, because whenever carbon monoxide inhaled by any living or human being, because it will compare with the hemoglobin, combines it compared with the oxygen and combines with the hemoglobin, and the strong binding tendency will be there, and it will retard the absorbance of oxygen, so that that blade is not sufficient to absorb the oxygen, and oxygen transportation in the entire body will become difficult, and oxygen transportation may not be possible. Oxygen is very essential for all smooth the functioning of harmonic metabolic activities in the entire body. So if oxygen's transportation is failed, what happens? That may causes anemia and severe damage of that blood is possible, that will become toxic, and chronic anemia is a major consequence of this carbon monoxide accommodation into the human being. So if it is in the extremely larger quantity, that may cause the fatal death of that living organisms as well, so that it is not at all preferable. So here gray hydrogen is not preferable. This should be properly treated so that here hydrogen can be extracted, and that will give the useful impact on the environment as well as on the human society as well. So here combustion get carried for this natural gas get treated with the steam, hot water vapor, so that here carbon turned into a carbon monoxide or carbon dioxide. Hydrogen get converted into a gaseous hydrogen, which is actually required for us as a fuel. So this is the system where gray hydrogen got generated, and let us see what is meant by blue hydrogen in detail. Blue hydrogen, again, we are taking natural gas as the starting material. Only the slight differentiation between the gray hydrogen and the blue hydrogen will be the emitted product like a carbon monoxide or carbon dioxide get captured by the process called carbon capture, usage and storage. CCUS is regarded as a carbon capture, usage and storage. So the extent of carbon dioxide emitted during the combustion process, during the chemical transformation process, get entirely captured, so that here that will not show any kind of adverse impact on the environment, and hydrogen get released during the process, utilized for the various applications. This is a sequential arrangement of water molecule, sorry, natural gas was taken, and carbon monoxide or carbon dioxide get released. If partial oxidation is there, adequate quantity of oxygen not available over here, then carbon monoxide get evolved. Excess of oxygen is available, then it carbon completely oxidized and converted into carbon dioxide, and that will be reformed, and hydrogen got extracted. And so here the device called the carbon capture, usage and storage is available in order to absorb the entire carbon dioxide, being it is a sink for this carbon dioxide. So here this is regarded as a blue hydrogen. It is also having equal kind of a potential as a green hydrogen. So here blue hydrogen, what a sequential production plan is provided over here. Methane, being it is the major component of the natural gas, was taken into the consideration and converted into a hydrogen, and the carbon dioxide evolved at high temperature. So here thermal chemical transformation get carried over here. Carbon dioxide, whatever released permanently stored, permanently absorbed by the device called a carbon capture, usage and storage system. Hydrogen is an essential component for all our daily life applications, for electricity production as well as a clean energy generation, even for the transportation fuel, power generation, and warming the buildings, and even sustainable survival of the cities and the rural region. This get applied, and even for the industry it will become the primary fuel. So this is about the blue hydrogen. Now let us see similar green hydrogen. Pink hydrogen is made via electrolysis but using nuclear energy. So pink hydrogen is another kind. Here also water get electrolyzed, but electricity generated during the process of nuclear reaction. Nuclear fission reaction get carried. Some of the elements of higher nuclear size are having less stability. So here especially block elements are being treated as a radioactive in nature because of larger nuclear size. In order to get the stability, they are having continuous emission of the radiation over, and alpha, beta, gamma radiations are emitted by these nucleus. Purely this nuclear process are so this kind of fission and fusion reactions are nucleus oriented, and here this nuclear process are used to generate the large amount of energy. So here that energy can be utilized for the electrolysis of water, and subsequent hydrogen evaluation is possible, and that can be applied in the various purpose. This is regarded as a pink hydrogen. Now another type of hydrogen called yellow. Yellow hydrogen, just now we discussed, yellow hydrogen is nothing but again here electrolyzer is the device where electrolysis of water get carried in order to split water into hydrogen and oxygen. Oxygen directly evolved in the environment that may increase the quality of air, because oxygen quantity will be the measure of the quality of air. Greater the oxygen quantity in the air, greater will be the quality of air. That will not show any impact on the environment. And hydrogen generated during the process get collected. For this kind of electrolysis process, what we are using, we are taking sunlight into the primary consideration. Solar panels are arranged in such a manner, and they are collectively converting solar radiation into the electricity. This electricity now utilized for the splitting of water molecules in the subsequent oxygen and hydrogen molecules. Gaseous molecules get released over here. This hydrogen gets stored and can be utilized for the fuel cell, and even for various other applications as well. So here pure concern is about solar radiation get harnessed by means of solar panels, and they get utilized in the splitting of water molecule, and hydrogen gas is evolved during the process, and this get applied in the various purpose. This is regarded as a yellow hydrogen. Now, let us see global hydrogen consumption by the industry, how extent hydrogen produced in whatever the means of production it will be. Then what kind of applications are adopted for this produced hydrogen? In general, measure quantity of hydrogen generated by means of various process, that may be green, that may be yellow, that may be blue, all these. So the applications purely lays in these sections. Here, the major content of hydrogen synthesized can be utilized for the fertilizer manufacturing. The major fertilizer NPK among all nitrogen is very essential for the plant to grow in the croplands. In this ammonia production, the 55% of hydrogen generated get utilized over here. Already we are most familiar for the ammonia synthesis is carried by the process called the Haber process. In that Haber process, we are using this hydrogen, the major quantity. This is the major portion of hydrogen synthesized get utilized. Later on, petroleum refining process. Petroleum is a crude product which extracted from the natural source and from the earth crust nearby the ocean regions, where hydrocarbon mixture will be there along with the other contaminations like a sulfur, nitrogen, and other impurities also associated. Petroleum refining stands for purification of petroleum oil, especially in order to remove the sulfur content from this petrol, because if you are not removing sulfur, that may combusted during the fuel combustion, so that your environment get polluted by sulfur oxide pollution. So that is hazardous in nature. So here, during this petrol refining, especially in order to remove the sulfur, hydrogen is very essential. The second most contribution of this hydrogen for the purification of petroleum oil crude product desulfidation process, this hydrogen get utilized. And another 10% for the methanol production. During the methanol production, your carbon and hydrogen, this hydrogen is contributed by the hydrogen gas itself. So here methanol is very essential chemical of hydroxy compound. It is the major source of what we can say in the reagents as well as in the chemical industry. It is the major solvent, and so many materials are synthesized from the starting material as well. So that here methanol production also, here hydrogen reduction is required in industrial purpose. Another part will be for all our applications what we are saying as automobile fuel. So here automobile fuel, whatever electricity, so this minor contribution is provided as of now, but in the future there will be a greater concern. This will become a major quantity. So wherever automobile and also like electricity production and fuel cell construction, so all these are becoming the primary importance with respect to the environmental consciousness. That's the reason why this will. So this is indicated with the green part because it is a sustainable factor especially. So that's the reason why its contribution will be increased in nearing future. Now let us see where we can use this hydrogen. Hydrogen is a very essential element. Just now we discussed in the manufacturing of fertilizer. Haber-Bosch is the process where ammonia synthesis is possible. Ammonia is the major nutrient material in order to grow the plant species in the croplands. Whatever the plant species, NPK, these are the major nutrient species. Along with them, minor nutrients also required, but the major nutrients will be NPK, nitrogen, phosphorus, and potassium. Right. So in the Haber's process, nitrogen get reacted with the hydrogen. Hydrogen is treated in the presence of catalyst. Iron can be taken as a catalyst over here, and extremely large pressure conditions get applied. 1,000 atmospheric pressure applied in the temperature will be 500 ambient temperature conditions will be applied. Nitrogen get mixed with hydrogen in the presence of iron catalyst, and formation of ammonia is possible. This is a major or fertilizer. And this is a major role of hydrogen in the industrial application. So here NPK, nitrogen, phosphorus, potassium are very essential for the healthy survival of a plant. So nutritional crops will be yielded when these are in the adequate quantity in order to grow them. So among all these, the nitrogen synthesis Haber's process requires hydrogen the major quantity. And in either application of this, hydrogen will be automobile fuel. Power is generated converting chemical energy into a mechanical energy, especially in the automobiles, wherever chemical energy is there in the fuel. Whatever the fuel we are taking into the consideration, that get converted into a mechanical energy, movable energy, machinery, movable energy. So that is the major kind of transformation in case of automobile fuel application. Right. So here fuel get combusted in the presence of oxygen, because the combustion, the very essential element will be oxygen. Electrical motors or internal combustion process get carried. If you are taking even petrol, diesel, all these also combusted internally and subsequently converted into energy that used to move the vehicle. So in the similar manner, here also hydrogen is combusted in such a manner in the presence of excess amount of oxygen. The power generated will be higher in the efficiency when compared to remaining all the fossils. So here high proficiency will be there and zero environmental impact over. That's the reason why it is regarded as the most efficient automobile fuel. So here hydrogen fuels for the motive power, hydrogen vehicles includes the hydrogen fuel space rockets, automobiles, and any other transportation vehicles as well. So here now there is a great research and great efforts regarding this, making hydrogen into a fuel to run the vehicles. Right. So here some of the chemical theory was provided over here, how the combustion get carried and how the energy released during the combustion of hydrogen. So as we are aware, there 2 moles of hydrogen will be combusted in the presence of 1 mole of oxygen, and subsequently water get released as a product along with the excess amount of energy. From where excess amount of energy is coming? Let us see energy calculation perspective by means of transition state theory. In order to explain this, we are having 2 moles of hydrogen and 1 mole of oxygen, where energy profile is provided in the one y coordinate and the reaction progress is provided on the x coordinate over here. Right. Hydrogen atoms when hydrogen molecules when combined with the oxygen, what happens? They will reach their transition level, so that will be rise in the energy. So because by the ignition process, we are providing the excess amount of heat to them so that they are going to excite. This is said to be activation energy, which is required in order to combust this one. After getting this one, so what happened? They get transformed into a product of water. Water is ultimate product over here. So whose energy will be extremely low. Along with these products, whatever energy difference is there, that energy will be liberated over here. So that is the driving force for these automobiles. Hydrogen upon combustion with oxygen, what happened? The air product generated comparatively lower in the energy, and the energy evolved during the process is used to drive the vehicle. This is the phenomenon involved in the automobile. How can we use this hydrogen as the automobile fuel? Right. So here, how far will 1 gallon of hydrogen will be equivalent to the natural fossil fuel? We have the comparison over here. 1 gallon of gasoline exactly equivalent to the 1 kg of hydrogen. So this is the quantitative comparison between the fossils and this hydrogen. 1 kg of fuel hydrogen combustion will equivalent to 1 gallon of gasoline nothing but petrol in general, right? So here hydrogen of 1 kilogram, 8 kilograms of oxygen required for the complete combustion of this one, and water evolved during this combustion process will be 9 kilograms will be evolved. So this is the quantification in terms of their combustion process. and a comparison with the fossils also provided over here. 2 moles of hydrogen get combusted in the presence of excess of oxygen, so that water molecule evolved along with the liberation of energy. So energy is evolved. Why? What could be the reason for that one? Because the product produced will be lower energy when compared to the starting materials. This energy difference will be liberated in the form of exothermic heat, exothermic energy that can be utilized for the movement of these vehicles, automobiles. So it is 100% energy efficient in nature. So here all the countries are planning towards this hydrogen fuel stations. So just like our hydrogen fuel station, diesel fuel station, and even natural gas fuel station is there, LPG fuel station is there, auto gas fuel station is there. Likewise, there is a upcoming trend for these hydrogen fuel stations. So here hydrogen very safe to handle, and even safe to environment, and very economic in the nature. So available abundantly and economically, this will lessen or reduce the burden of fuel imports, because water available everywhere, we can transform that water into hydrogen, so that subsequently it will become the greener fuel and efficient fuel as well. So now let us see how it can be utilized for the refining of petroleum. What is the role of this hydrogen in the refining of petroleum? Refining of petroleum deals with the purification of petroleum, because petrol available in the earth crust with the all contaminations whichever available in its surrounding. And moreover, it is composed of a range of hydrocarbons instead of the specific hydrocarbon composition, right? Petroleum is composed of hydrocarbons of C1 to C30. Lower hydrocarbons are gaseous in nature, in between hydrocarbons are liquid in nature, and higher hydrocarbons are solid residue, tar type of materials will be there. All right. Along with them, other contaminations like sulfur, nitrogen, other impurities may be associated with these petroleum oils, so that without proper treatment, petroleum oil may not be suitable for the automobile fuel consumption. That's the reason why proper treatment, proper purification is required. That is the process called refining. During the refining process, what's the role of hydrogen? Let us see. Hydrogen for the refineries is increasingly provided by the industrial suppliers. It is the second most primary use of this hydrogen. Petroleum refineries use hydrogen to lower the sulfur content in that. Lesser the sulfur content in the fuel, greater will be the efficiency of that one, because being it is also a kind of a combustible material, but after the combustion, the emissions or subsequent emissions are not at all preferable for the environmental healthiness. That's the reason why sulfur may not be preferable to be associated with any kind of fuel. So here sulfur removal requires the addition of this hydrogen over here. So refinery demand for the hydrogen has increased, and demand for the diesel fuel has risen both domestically and internationally. So even at local level, national level, and even international level, the sulfur removal is the primary implication. That's the reason why hydrogen is majorly applied for this kind of refining or purification process. Sulfur from the fuel is removed by the chemical process called hydrodesulfurization. What is meant by hydrodesulfurization? Desulfurization is nothing but removal of sulfur. Hydrodesulfurization is nothing but by the addition of hydrogen, we are removing sulfur in the form of dihydrogen sulfide. That is the chemical process regarded as a hydrodesulfurization. Right. Hydrogen binds to the sulfur and is converted into hydrogen sulfide. That is a rotten smell material that get combined product evolved during the process. So the sulfur will be discarded from this petroleum oil. This is a kind of refining to remove the sulfur. So, and further this hydrogen sulfide emitted from this refining process will capture and process in a proper way in order to detoxify that into the environment. The supply content is the indicator of quality of the crude oil, determines the process of steps that are required for the refining. And sweet process, sweetening is nothing but sweetening of petrol is nothing but removal of sulfur. That is the commercial name for removal of sulfur, sweetening of petrol. So here the low sulfur content can be possible by the addition of this adequate quantity of hydrogen, so that here it will be removed in the form of dihydrogen sulfide. So this is a kind of refining of petroleum oil. Now here it is shown to us how it will be possible. Petroleum coke was taken in coal gasifier will be there. Hydrogen evolved along with the carbon dioxide. Hydrogen liberated can be used for the hydrogen power station. And this hydrogen, wherever we have applications like electricity, like a fuel, we can apply, and even fertilizer production, this hydrogen can be utilized. And carbon dioxide evolved can be treated and permanently captured by the carbon capturing and usage storage system. So this is a kind of hydrogen production process. Now, where we can use this, lower the emission to cure the nature, where we can use hydrogen, power of the pure, and lower the emission to cure the nature. How can we say hydrogen is efficient for the human as well as to the nature? Now let us see. During the power generation, hydrogen is one of the leading option for the storage of renewable energy. Hydrogen and ammonia can be used as a gas turbines to increase the power system flexibility. Ammonia could also used in the coal refining and power plants. So not only hydrogen directly, but also there's ammonia produced. Now that is a primary application of ammonia will be fertilizer. In addition, we have application in the power generation in the thermal power plants like a coal refining process. Hydrogen fuel cell produce electricity by combining hydrogen and oxygen. When hydrogen oxygen get combined, what happens? The product will be water. No other emissions will be there. Hence, we can say it is very pure, efficient, and lower emissions. And in order to cure the nature, that's the reason, right? The chemistry involved in this hydrogen oxygen fuel cell will be hydrogen used to release the electrons, and that hydrogen converted into H plus, released H plus, and electrons get captured by the oxygen in the cathodic region, where reduction process get carried. Both are ultimately converted into water. That's the product generated in the fuel cell, and which is not at all emitting any hazardous gases into the environment, so that it will be a 100% eco-friendly in nature. Now let us see. As of the end of October 2021, 166 operating fuel cell electric power generators, 113 facilities in the United States with a total of 260 megawatts of power of electricity generation capacity was installed. So this is a kind of exploration and extension of this kind of products into the market in order to avoid the hazardous impact by the fossils and other kind of fuels. That's the reason why there is a extending consciousness towards this hydrogen to work as a fuel of the future. The largest single fuel cell is Bridgepoint Fuel Cell LLC, without 16 megawatts of generation capacity, was launched by the United States in order to produce hydrogen in the bulk scale. So the process is underway in order to synthesize hydrogen in the bulk quantity, and it will become the better and efficient alternate for the fossils. Samples of plastics. So here another kind of segment we are going to discuss with it, which is very much essential. How can we convert exhaustive garbage into the efficient hydrogen? So nothing will be wasted which is available in the universe. So because everything will be more precious, whichever provided to us, the thing is the perspective, in what way we are treating that material, right? So here, even the wastage, even the garbage, even the discarded products, whichever present, that can be treated in a proper way, so that it will become the valuable essential material and can be reused for several times. That will benefit the human as well as our environment, which present in our surroundings. That's the reason why I feel this will be the important segment of today's lecture. The samples of plastics were pyrolyzed in the bottom at the reactor. So plastic, what is meant by plastic? Plastic is again the polymer which is composed of carbon and hydrogen solely. That's the reason why by proper treatment, we can consolidate, we can exclude this hydrogen, and that can be utilized for various purposes. Solid carbon is not wasted again. It can be utilized in another purpose also, because this can be converted into either nano-sized particles, or else this carbon can be used in the manufacturing of roads, or else this carbon can be treated, taken as a starting material in order to synthesize all other materials of organic chemistry. In that manner, nothing will be wasted over here. That plastic is properly pyrolyzed. Pyrolization is nothing but rising the temperature to very high temperature conditions are regarded as a pyrolytic conditions, where plastic get completely liquefied, and proper fragmentation is possible, and hydrogen get collected over the catalytic conditions. Here catalytic conditions were employed in order to improve the efficiency of this entire process of splitting of plastic into hydrogen and solid carbon. Preliminary test showed that the process conditions similar to those of reforming natural gas, just like natural gas, because here also we are taking longer chains instead of the smaller fragments. The only the difference between the natural gas and plastic will be natural gas is hydrocarbon, plastic is also hydrocarbon, but natural gas is of smaller particles, the plastic is of longer polymeric chains. Here also there is a provision to synthesize the hydrogen from this garbage. Used plastics are taken as a starting materials over here. That's the reason why it is regarded as a exhaustive garbage is turned into efficient hydrogen. Now let us see how the chemical process get carried over here. We are taking the polymeric chain. Polymeric chains are made up of carbon and hydrogens in this manner. N denotes what number of repeating units present over here. The longer chain may be taken. So this plastic will be treated with proper commercially valuable catalyst, especially we are taking iron aluminum oxides. So iron aluminum oxides are taken over here, so that here fragmentation of these hydrocarbons into hydrogen and solid what happened, this concentration is possible. Further treatment, one more step, and we will get this hydrogen. So recovery of hydrogen will be high energy efficient, and here 97% recovery is possible without any wastage. Hydrogen may not be wasted over here. And here you can observe that the carbon generated may not be wasted again. You may convert into carbon nanotube material, so that here nothing will be wasted. 100% effective recovery is possible by means of this garbage to hydrogen process. But substantial protocols and substantial optimized conditions should be employed in order to get the effective collection of the final products over here. So this is a kind of system where garbage can be converted into a hydrogen. Now, California startup can convert rubbish, that is the garbage, would otherwise go to the landfill, otherwise incineration, because every day, especially in the urban region, the solid waste management is a primary problem, right? So municipal solid waste treatment, either landfill or incineration, these are the only the conditions which we can treat them. So if you are considering this garbage as a valuable raw material in order to synthesize hydrogen as a starting material, already the work is under progress. California startup was there where they are taking this rubbish into a consideration, and they are converting that garbage into a hydrogen. California startup can take the municipal solid waste and the rubbish thrown away by the homes and the business industrial regions. Plastic and hazardous medical waste is also taken into the consideration, and they are properly treating, and subsequently hydrogen is evolved as a clean fuel or efficient fuel by the cheaper process, because we are not purchasing any starting materials. We are collecting the starting material from the garbage. That's the reason why it is the more energy efficient, economically viable, and even environment friendly in nature, and it will become renewable because garbage will not be shortage. There is no shortage for the garbage. There is no shortage for the electrolysis process. So that hydrogen production will be continuous in nature. So this is 100% helpful for the production of hydrogen from the waste. Now let us see. Even in India, we have this same kind of initiations, same kind of footsteps towards converting garbage into a hydrogen. India has a target of 60% of renewable energy by means of 450 gigawatts by the 2030. This is the target of India. So here 450 gigawatts of energy by 2030. So mostly from these renewable modes of energy sources. This will be the target. In order to achieve this target, we are planning for the taking the various kind of renewable energy sources taken into the consideration. In this regard, the government is planning to avoid the carbon footprint and emissions, hazardous impact, everything will be subsided, and rather we have to increase the environmental consciousness. Eco-friendly conditions are taken into the primary aim of this production, this target achievement. For that purpose, agricultural waste, being India is agricultural based country, most of the people are working in this region for the food production. That's the reason why here the after cultivation, after extracting the crop yields, so the waste generated in the agricultural croplands will be a great challenge for the disposal. So most of the firing of that waste products that may cause the environmental pollution or land pollution as well. In order to avoid all these, there is an innovative plan in order to convert all these agricultural waste into a productive hydrogen. So here there is a process. So whatever cropland waste, farming waste will be there, that will be collected in such a way. And even from the dairy farms and the poultry farms, animal waste is also collected. Municipal solid waste is also collected from the urban regions. All all can be treated in the plant where the combustion will be possible in such a manner. Hydrogen is collected in the pure form that can be utilized in the various purposes. So this is a process which 100% helpful for the production of hydrogen from the garbage. So it is actually needed because both the benefits we will have. So garbage treatment will be fulfilled, and eventually hydrogen production target, whatever we have for the welfare of the nation. So subsequently, security of energy, security of environment, security of the nation will be possible by means of all these attempts. Now, a team of researchers from the Agarkar Research Institute, Pune, an autonomous institute, Department of Science and Technology, Government of India, and the collaboration with the scientist lab of KPIT Technologies have developed this technology and the lab scale to extract the hydrogen from the agricultural residues. These are the contributing research frameworks in order to convert these agricultural residues into the hydrogen. What are the entities? Agarkar Research Institute, Pune, and KPIT Technologies in accompanying with the DST Government of India. They are transforming this waste of agricultural croplands into a efficient hydrogen. So this is the process. This is a research in order to avoid the garbage and in order to synthesize the efficient fuel from this waste. Now, researchers from the Indian Institute of Chemical Technology, every other day, 6 months, 2017. So what they did, food waste, from the food waste, they treated with the dark fermentation. So microbial action was carried on the food waste materials, and entirely the material get converted into the liquid. So here during the fermentation process, methane is evolved. Along with the methane, in either products generated will be hydrogen, and biodiesel is also generated during the fermentation process. That depends upon the types of microbes we are employing during this fermentation process, right? So here all these kind of materials are generated. One of the prominent material will be hydrogen, so which is generated by the fermentation process. Let us see in detail. They collected the food waste in institutes cafeteria. From the institute cafeteria, they collected the garbage, especially food waste get collected and completely filtered. Large particles get discarded, drained the oils also removed and added it to the tower. So cylindrical tower was taken, which contains the anaerobic digester. Anaerobic digester is nothing but in the absence of oxygen. The reaction, entire fermentation got carried in the absence of oxygen, so that here oxidized products will not be evolved, right? So here anaerobic digester was taken over here, and the soap waste and bacteria was treated with that. Suitable bacteria and the soap waste is also added to that one. Munching on the leftover lunch, those microorganisms didn't produce the conventional biogas. Typical digesters will be there with some scientific innovation. Mohan and his team, these are the researchers who are working upon this. Microbial instead produced the gas which is having the rich in hydrogen. So they collected successfully hydrogen as a final product by the anaerobic fermentation of the waste collected from the food materials. So in either attempt in the same regard, garbage to the hydrogen production, the Purdue University will be there, where it is the landmark for the innovations. The scientists developed a method to improve the production of hydrogen from the food waste. Here they taken yeast as the fermenting material. Over here, in general, yeast is the main kind of system fermentation got carried. Fermentation is the chemical process where complicated hydrocarbons, complicated carbohydrates will be there. They get fragmented by means of these chemicals are enzymes secreted by the yeast, like zymase. So all these are used to fragment the complex food materials into the simpler form, so that yeast is utilized for the fermentation process and the production of hydrogen is possible, which is taken as a clean fuel. And large scale synthesis also possible with this, and raw materials were taken as the waste discarded as a food. Food waste can be collected, and anaerobic yeast fermentation got carried, so that a clean, efficient hydrogen fuel got originated from this. This is another achievement by the scientists, garbage to hydrogen production. So here biomass gasification is the mature technology pathway. Biomass is nothing but the energy source whichever available from various living organisms. You may take plant waste, you may take fallen leaves from the forest waste, you may take carpenter what we can say, that sawdust is also considered as a biomass. Wherever plant waste will be there, raw material taken as a raw materials, where the hidden energy will be there because of photosynthesis, the energy stored in the plant materials, right? So that can be treated as a biomass collected from the living organisms. Further, they get treated in a proper technology pathway. Biomass can be converted into a hydrogen, so that here this is also kind of a system where garbage to hydrogen is possible. Chemically, biomass is regarded as a lignocellulose. Lignocellulose is nothing but, so whenever photosynthesis got carried, what happens? They are used to produce glucose, fructose, like that. So that glucose get polymerized and stored in the form of cellulose. So cellulose is a special material which is available in the plants. So everybody is most familiar with this one. These lignocyanins are rich in energy, rich in hydrocarbons, and these hydrogens, whichever present here, they are treated in the proper technology, so that here hydrogen collection is possible. In this way also, garbage to hydrogen production is possible. US Department of Energy anticipates that biomass gasification could be deployed in the near term time frame. So this is also taken into the priority basis for the production of hydrogen from the biomass by the process called the gasification. Biomass get gasified, so that here during the gasification, carbon parts is discarded, and hydrogen will be collected as a clean fuel. So this is also the process for the production of hydrogen from the biomass is underway. Garbage to efficient hydrogen. And how can we convert organic waste into hydrogen? So that chemistry is going to be discussed over here. One method of generating hydrogen from the biomass begins as a processing organic materials. Organic materials may include that may be extracted from the natural origin, or else which are synthesized in the laboratory, or else which already used. So the materials which converted into the garbage, whatever the organic material you may take into a starting material here. This organic matter subjected to high temperature conditions without any combustion. We are not supposed to do any combustion over here. Just we are rising the temperature. So combustion is possible whenever oxygen is there. So that entire organic matter will be rise to high temperature in the absence of oxygen, so that combustion will not be carried over here. When combined with the oxygen, steam, the reaction results in the carbon monoxide, carbon dioxide, and hydrogen. So here, rising the temperature, the hydrogen gas evolved, and subsequently, the carbon which are present in the organic matter will turn into a carbon monoxide and carbon dioxide based on the availability of oxygen over here. So this is a kind of organic waste into hydrogen, and this is a plant which used to carry this process. So we are taking the garbage, we are taking the organic waste, we are taking the plant materials and raising the temperature to very high, and whatever hydrogen matter is there get converted into gasified clean hydrogen fuel, and any other byproducts will be evolved, either carbon monoxide or carbon dioxide, that should be properly treated. And we have a concern regarding this hydrogen production. There is a international entity in order to get the energy security, that is designated as International Energy Agency. IEA is an international agency which used to give the protocols, how the framework should be there in order to synthesize the safe energy. So they're also fetching toward this hydrogen synthesis. Producing hydrogen from the low carbon energy is costly at the moment. International Energy Agency analysis finds that the cost of producing hydrogen from the renewable electricity falls in 30% by 2030 as a result of declining cost of renewables and scaling up of hydrogen production. This is a target fixed by International Energy Agency. What is the target? By 2030, electricity from the renewable sources should be covered with the 30%. Fuel cells, refueling equipments, and electrolyzers, which produce the hydrogen from electricity and water, can all benefit from the mass manufacturing. So this is the target they are fixing for. Here, power generation, buffering, transportation purpose, we can utilize industrial energy. This hydrogen can be utilized building, heat, and power. So building, in order to heat the buildings and the power supply, we can utilize this hydrogen as a fuel, and new feedstock will be there. So in all these cases, hydrogen can be utilized in the safer manner, and they are putting the target for 2030, 30% of energy contribution should be coming from renewable sources. This is a primary concern by the International Energy Agency. Right. And future perspective in the hydrogen chemistry, India, how we are moving towards the future with respect to this hydrogen production. What will be the perspective of India? And the Independence Day speech of Prime Minister Shri Narendra Modi announced 5 key initiatives. One of the major initiatives will be a Mission Hydrogen, National Mission of Hydrogen. India should become the international hub for the hydrogen production and even for the export as well. So it should become the global leader in enabling substantial domestic hydrogen economy. Hydrogen economy should exponentially rise. We have to go and we have to move forward for that extent the production of hydrogen in various from various kind of starting raw materials. We can collect this hydrogen, and hydrogen production is ultimate motto for this national mission of hydrogen production, being it is a efficient and cleaner kind of fuel. And ultimately, India should become the energy deficient to energy rich country. This kind of transformation they are planning for. This will be the future perfect perspective of India in this hydrogen regard. So it can even make in India, it is a part of Make in India scheme, because the entrepreneur should come forward to facilitate the process of hydrogen synthesis, and India should become the exporter of energy. Hydrogen is considered one of the most sustainable, substantial fuel of the future. This is a target for India. By the year 2020, it was a record year for the policy actions and low carbon hydrogen production. So record production of hydrogen was carried ever since in the year 2020, with the 10 governments around the world adopting hydrogen strategies. And closure to 70 megawatts of electrolysis capacity was installed, and doubling the previous year's record, in two facilities producing hydrogen from the fossils, with the carbon consuming utilization system became operational, expanding production capacity of 15%. This is a record level rise in the production of hydrogen in the year 2020 all across the globe. And they are preferring to synthesize this hydrogen in the bulk scale, and we achieved till now 15% rise in the production, and still there is an aim for rise the production of hydrogen in the near future. Green hydrogen produced through the renewable sources such as solar, wind power holds a significant promise in meeting the world's future energy demands. So as already we are aware that the global population is rising exponentially, they demand for the energy seeking. So we are purely laying on the energy, various kind of means of energy sources for our comfort, for our survival. As the technology induced world is preferring this cleaner, efficient energy for all means of operations, all means of applications. That's the reason why green hydrogen green hydrogen demand is rising exponentially. In order to meet that energy demand, future energy demand, there should be a rise in the efforts to synthesize this hydrogen in the exponential way. So here, availability of renewable energy sources very widely. Recently, PwC analyzed that green hydrogen market worldwide is identified potential demand growth and cost trajectories per country, and most promising export and import market. The result gave policymakers and industry leaders guidance on how the future market for the green hydrogen could evolve. So here, how the green hydrogen synthesis is possible, in what way it can be applied in order to meet the energy demands of the world in the future. So that is the major criteria by International Energy Agency. In that regard, they are taking the initiatives to rise the synthesis of this hydrogen in a bulk scale, industrially viable scale. So this is a kind of chart report which is provided. Renewable sources of energy, either wind power, solar panels, can use to harness the energy from the nature. And this energy can be utilized for the electrolysis of water, a splitting of water molecule, and the hydrogen collected in the bulk form. And this hydrogen can be used to equip the fuel cell made up of hydrogen oxygen. And this is more energy efficient, and the product generated will be a water that can be collected, no more wastage and no emissions into the environment, and the energy generated can be connected to a grid. That means a bulk scale synthesis is also possible. Now we can see hydrogen neither fossil nor fugitive, but found amply in nature, hence undeniably fuel of the future. I would like to repeat one more time. Hydrogen, neither fossil, that is not a fossil fuel, nor fugitive, that is not discardable, but found amply in a nature, abundantly available material, hence undeniably fuel of the future. That's the reason why we can say with confidence, hydrogen is considered as a fuel of future, right? So thank you very much. Hydrogen, powerful, accomplishable for next gen. Hydrogen is a powerful, accomplishable for next gen. By this, I would like to conclude. Hope this session will be helpful for everyone. I think, because we are facing so many problems with the different kind of fuels we are using now. If we switch for this cleaner hydrogen, so it will be more energy efficient, and it will give the energy security, economic security, and even environment security. Thank you. Thank you everyone for your consistent listening. Thank you one and all.